everybody. Welcome to this talk about writing Elm applications using Vite. Today, we're going to explore the Elm programming language, a functional programming language for building web applications, and how we can integrate it into our Vite build tool. My name is Lindsay Wardell. I am a software engineer at No Red Inc. No Red Inc. is developing tools for English teachers to teach middle and high schoolers English and writing. We also get to use really cool programming languages such as Elm and Haskell. If you like these cool programming languages or you like education, please consider applying at noredinc.com/jobs. I am also the maintainer of the vite-elm-template that incorporates Elm and Vite and a lot of the tools that we're going to be talking about today. We're not exploring the template itself, so please check it out at lindsay.kwardell/vite-elm-template on GitHub. First off, let's just dive in. What is Elm? Elm itself is a functional programming language. Functional programming is very in vogue right now in the JavaScript ecosystem, but Elm is designed as a functional programming language, unlike JavaScript, which is very object-oriented or imperative. It also only has pure functions. So if you're thinking of JavaScript and you call a function, you can make side effects. You can do other calls. You can, if you're in the Node environment, you can make malicious calls. You can do bad things. Elm doesn't allow that. Elm only has pure functions. So only the inputs provided to the function are the values available, and the only outputs are the output of the function itself. Elm also compiles to JavaScript. So when you are writing Elm code and you compile it for the web, you are running a JavaScript file. This makes it really easy to incorporate into your existing applications and build environments. Elm is also statically typed. It has a strong static type system. This is extremely powerful. If you've used TypeScript, you've had a feel for it. But Elm takes it to the next level where everything is strongly typed. All of your functions are expected to return certain values. And because of that strong typing, you get a lot of assistance from the Elm compiler itself, which we'll get to in just one second. Elm also supports immutable data as a built-in concept. Elm doesn't allow mutation. There aren't any objects that you can then manipulate and modify. You're just going to have the data that you expect. And as I mentioned, there are helpful error messages in Elm. So when you are working on your code base, if you change a type or if you start refactoring in one part of your code, the rest of it will not be in sync, and the compiler will know that and tell you what's going on and what's the best way to help work through all of those changes. And also, this is a fun one, there is no null, there is no undefined. You will never have undefined cannot be found in your runtime. And in fact, there are no runtime exceptions for the most part. If an Elm application compiles, it works. And when you write your Elm code and you deploy it to the web, you can be sure that it may not be doing everything by the business logic that you want it to do, but it will not crash when your users are using it. So let's just do a quick comparison between the JavaScript and Elm ecosystems. In JavaScript, if you wanted to start an application and install some packages, you'd probably reach for npm or yarn or pnpm. And in Elm, this is all built in. You just run Elm install and you install something. If you want to build, you run Elm make and it builds something. It's pretty neat. In JavaScript, if you want to build a web application, you're going to reach for React or Angular or Vue or Svelte or Solid or whichever framework is your preference. And in Elm, this is all built in. We follow the Elm architecture, which is just a core foundational piece of the language for building web applications. In JavaScript, if you want global state management, you need something like Redux, NGRX, Pinya, whatever your preferred flavor of global management is. And in Elm, again, this is built in. It's part of the architecture of the language. All of your state lives at the global level and then gets passed into functions. Remember that none of those functions can call that data except if it's passed in as an argument to the function. In JavaScript, if you want immutability, you need to reach out for a third-party library or use something like object.freeze, which is not 100%. There are some proposals on the way for records and lists that are immutable, but they're not here yet. In Elm, however, they are all built in. This is the default and the only way that you can work with data in the Elm language. In JavaScript, if you want types, you need another third-party tool, TypeScript. But in Elm, as we discussed, static, strong type systems are built into the language. In JavaScript, looking at some tools outside of the programming itself, if you want to lint your application, you have ESLint. And in Elm, there is Elm Review, a similar tool that allows you to configure in Elm how your code should be linted. In JavaScript, you have access to Prettier so that you can style your code. This can also lead to a lot of debates within your team. Should we put the dangling comma at the end? Should we use a single quote or a double quote as the default? What about semicolons? In Elm, there is Elm format. Elm format formats your code for you. There is no configuration. It follows the standard provided on the Elm website for how code should be formatted. And in JavaScript, if you want to do unit testing, you're going to reach for Jest, Mocha, vtest. There's a number of libraries that you could use. But in Elm, there is Elm test. Elm test allows you to write tests in Elm for Elm and run them with a simple CLI tool. Some of the other niceties about Elm are the helpful error messages that the compiler gives you. So for example, if there is an incorrect argument type, let's say we're calling string.fromInt but passing it a string, the compiler will tell us that that is a string, but fromInt needs the first argument to be an int. If you want to convert a string into an int, use string.toInt. So Elm is very helpful in this way in providing us hints and guides as to what the code is expecting or what you might have actually meant. Another case is the invalid case. If you have an if statement and you're returning a value in a function, that's the only kind of value that can be returned from a function. So if the start of our if statement returns a string and the middle returns a string and the third value returns a number, that's not valid. The third branch is a number of type number, but all the previous branches result in string. And then it tells us that all branches in an if must produce the same type of values, and then gives us guides on how we can write custom types that can incorporate different types of data if we really need to do that. The third example that we have today is truthiness. In JavaScript, we have this concept of truthiness. If you want to know that a list has data, you can typically just call, like I'm demoing here, string.length and then a string. If that comes out to any number but 0, then we know that the string is present. There is data there in JavaScript. But in Elm, that's not how it works. In Elm, if you want to make this kind of comparison, you need to actually determine that the string length is greater than 0, because Elm does not have truthiness, as we can see in the hint. Elm does not have truthiness such that instance strings and lists are automatically converted to Booleans. Do that conversion explicitly. So again, Elm's compiler is actually guiding us through the process of learning how to work in Elm. And this is an example of some Elm code. It's very basic. All we're doing here is adding a counter to the screen with a plus button and a minus button so that we can increment and decrement a number that is re-rendered on the screen as the number changes. So let's just walk through this file real quick. At the top, there is module main exposing everything. So the ... it means everything. Module main is the name of the file, and it's at the root of our application. And then we are importing 3 different packages: the browser, so that we can actually create an application; HTML, so that we can render HTML. It's kind of important. And import HTML.events, so that we can actually have events in our application, allow the user to interact with the page. We then initialize our state, our model, to be 0. So in this case, our data is just a number. We're not worrying about anything complex, and it just starts out at the number 0. We then have our update function. The update function takes a message. In this case, the message is a union of either increment or decrement. And then our update function itself has a type signature where it takes a message and a model, and it returns a model. So on the next line, we can see update message model. We have those as variables now. Case message of increment, model +1. So we're increasing our model, which is a number, +1. And if we decrement, model -1. And then in our view, we have some HTML that we are rendering. So this is the structure for rendering HTML. If we want to render a div, actually any HTML element really, we have the element we are calling, which is itself a function, div in this case, with 2 brackets for the attributes. In this case, the div has no attributes. And then a second set of brackets for a list of children. So the div has no attributes, but it does have children. A button has attribute of onClick decrement, and then a child of the text minus. We then render another div with no attributes and the text of the model. So we're turning the number into a string so we can render it to the UI. And then we have another button for incrementing. And we are going to see this later in our code examples. I just wanted to walk through what this Elm code did before we got there. And then we have our main function. The main function is what is used to actually initiate the application, to render something to the browser. So in this case, we're using browser.sandbox. This just means it can't communicate with JavaScript outside of itself. And then we initialize init equals init, update equals update, and view equals view. This should look somewhat familiar if you are used to JavaScript object notation, but instead of colons, we are using equal signs. And this is a basic Elm application. You could start here, you could start expanding, you could start exploring how to write Elm itself. And right now, we're just going to look at how we can get started with Vite and Elm together. So we're going to go into some code. I have an example Vite starter using TypeScript, and we're going to incorporate Elm into that starter and render the counter that we were just looking at to the DOM. So this is the main.ts file. We're importing some styles. We're importing the TypeScript logo, setup counter, and generating some HTML. And we are just going to delete all of this in just 1 second. So the first thing we're going to do is install the plugin for using Elm inside of Vite. So we're going to do npm install Vite. Vite plugin Elm. And that will give us the plugin to use Elm inside of Vite. If this is the first time you've used Elm, you'll also need to do npm install global Elm. That will give you the Elm compiler and all of the language pieces that you need in your global and scope. I've already done that, so we're not going to do it here. The next thing we need to do is initiate our elm.json file. And to do that, we just run elm init. And we say yes. If you've never used Elm before, you should check out that link, just like it's saying. But elm.json is the equivalent of a package.json file. So it has our dependencies and what kinds of sources we're looking at and what kind of code we're writing. So now that we have all that in place, we're going to create our Vite config. Vite.config.ts. We're going to import define config from Vite, and we're also going to import plugin as Elm from Vite plugin Elm. And then we export default define config plugins Elm. And now we have added Elm into our Vite configuration, so we can start importing Elm code. So let's create a new file, main.elm. All Elm modules start with a capital letter, so capital M for main. And we're just going to dump this in. This is the same counter that we were looking at just a little bit ago. With that done, all we need to do now is delete everything. Always the best part. We're going to import Elm from main.elm. That gives us our application. And then we're going to do const app equals elm.main, which is the name of the file, .init. And we need to pass it a node. The node in this case is going to be an actual DOM node, document.query selector app. And that is all we need to do in order to get Elm working. So let's run npm run dev. Everything compiled happily. And we can see here we have our application. It's so exciting. It's a counter. What's really cool, though, is we also have the time-traveling debugger. So we can walk back in our code, every step we made, and see all of the changes that happened to our model. So when debugging something, this is a great way to see what's going on, what the current state of your application is, and you can start reasoning about what you need to do next. And it's just built into the plugin. So you don't need to worry about installing a plugin to your browser. It's just part of the Vite plugin Elm that you're bringing with you. And also when you're viewing the debugger, Elm will pause so that you can see what the state is when you move it to a certain place. And when you click to resume, it moves back to where it should be at the current state. Great. So now we have rendered Elm to the DOM using Vite, but we're not starting from scratch. We're not writing a whole brand new application here. What if we have an existing project? What if you've been writing a project in Vue for some number of months or even a year, and you really want to try out Elm, but you can't just throw everything out that you've written already? Well, you don't need to worry, because Elm can actually be incorporated into any of the front-end frameworks, whether it's Vue or React or Svelte or Solid, what have you. Elm, especially through Vite, can be added very easily into any of these frameworks so that you can give it a try. So that's what we're going to do now. We're going to dive into the Vue starter using npm create Vue and see what it feels like to add Elm into our application. All right, so now we're going to look, like I said, at the Vue 3 default template. And if you've never looked at it before, it's quite pretty, isn't it? And what we're going to do is, just like we did before, we're going to be adding Elm into this page. But instead of replacing everything, we're just going to stick it here underneath where it says support view. And let's jump into the code. As we did in our last example, the first step is to install npm install vite plugin, if you spell it right, Elm. And we already have Elm installed, so we can run Elm init, and we can get our Elm config up and running. And because we're using the Vue template, we already have a vite config file, and we are already importing Vue. So we're just going to add Elm in this case. Import Elm from Vite plugin Elm, and then just add it right here. So now we have both Vue and Elm as plugins, and that's all we need to do in order to have Elm up and running. So now we're going to create, just like we did before, we're going to create our main.elm file, paste in the exact same code that we've been using. It's the same counter, rendering the same HTML. But this time, instead of replacing all of the code, we're going to render this inside of Vue. So let's take a look at what you need to do that. For this example, we're going to be sticking it inside of the welcome. The welcome in this case is right here. And you can see where we've got documentation, we've got tooling, and we're just going to add one at the bottom as a welcome item to talk about functional programming. So we'll just start here with a welcome item. And first we'll add a template icon, and we're going to use an icon over here like this. And then we're going to add template heading functional programming. And this is where our Elm is going to go. So for now, let's just put a div. This is where we're going to render our Elm application. So now in our imports, we are going to import our application just like before. Import Elm from, in this case, it's a level up, main.elm. We're also going to import two of the Vue composition API features. We're going to import ref and onMounted. Now that we've imported these, the first thing we're going to do is say const elm node equals ref. And we don't need to put any values there. We'll use it in just 1 second. And then we're going to use the onMounted hook. OnMounted, we're going to say const app equals, same as we did before, elm.main.init. But in this time, instead of using a document query selector, we're just going to say node elm node.value so that we can access the value inside of that referential object. And that will instantiate our app, except Elm node is currently empty. So in Vue, in order to use a ref, we need to define that on the DOM element itself, div ref equals Elm node. And that's all we need to do. At this point, everything should be working as expected. npm run dev. And if we jump back over here, we see our debugger, we see functional programming, and we see that the Elm application is running. All right, let's recap what we've looked at today. When you're using Elm and Vite together, what you have is a functional programming language that you can use in the front end. You're not tied to the back end. You're not just worrying about data models and abstract theories. You're actually getting to write code that appears in the browser, which is always so much fun. You also have a helpful compiler that is guiding you as you're refactoring, as you're learning as well. And you're not having to worry about the runtime errors that you can run into in JavaScript. No, cannot read, null of undefined, or any of the issues that come up in JavaScript development. You're not going to run into those runtime issues because Elm just avoids them altogether. You also get a simple configuration with Vite. With one line of code, you can add Elm into any Vite-based application. There are also options if you want to configure the plugin to do other things, but by default, you're probably not going to need that. And with that, you can add Elm to anything. You can add it to a standard Vite template. You can add it to the Vue starter. You can add it to Astro. You can add it to Solid. You can add it to Svelte. Wherever you want Elm, you can add Elm there and try it out and see how it feels. And that is the next benefit, straightforward integration with existing applications. You don't have to throw out your code base that already exists. And in fact, that's highly it's highly recommended that you do not do that. If you want to try out Elm, the best way to do it is as an experiment in an existing code base, an existing application, and focused on one single feature. That way you can get a feel for Elm in that one place. And if you or your team decides this isn't the fit for you, it's really easy to either back out or not, just leave it there. But it's only that one feature. You don't have to worry about, oh, we rebuilt our entire single page application and now we're stuck. You can just keep it in that one spot or take it out altogether, whichever your team's preference is. So with that, I just have one question for you. What are you waiting for? I highly recommend you give Elm a try. I've loved working with it, and I think you will too. I hope you enjoyed this talk. I hope you learned a lot. I'm always around online if you want to chat and discuss these kinds of things. You can find me on Twitter at Lindsay K. Wardell. I'm also available to chat about Elm on the lunch.dev Discord server. Hope to see you around. Have a great conference.